Okay, so we've seen some ways that we can use the transformC function to transform a variable, like standardizing the abortion rate observed in different states in the country. This is what the raw version looked like, and I showed you what it would look like if you standardized that variable. Now, one thing to note here is transformC returns the transform variable. It gives you this warning message about not, make sure you don't overwrite data, but it's just outputting this now, and it's not saved anywhere where we could use the standardized abortion rate in some analysis. It just kind of showed us this one-off and displayed it, and there's nothing more to it. It's not saved in any way. So what you would need to do then, the transformC function will output the transform variable, but doesn't save it. So to save it and use it in some subsequent analysis, you would need to save it as an object or a variable within an existing data set. So I might say that the new variable called z dot abortion rate will be set equal to the result of this transformC function. So that state z abortion rate is assigned the value, the output of the transformC function. Let's run this. Do you want to continue? Yes, we will continue. So now you can see in my environment a new variable, a new object appears, and this new instance of the state's data set has an additional variable that that's stored, and I can recall called the state abortion rate. And now maybe you can see why we have that confirmation in here. It's very easy, and this is a somewhat a difficult mistake to remedy and you want to avoid, is if I'm not going to do it, but if I were to run this, state's abortion rate is equal to the transform version of the abortion rate, the original data would be overridden by the transform version. So I would no longer have the original, and in its place I would have the standardized version. So you always want to make sure you have given that a different name, like z dot abortion rate, so you keep the original intact but can also use the transform version if you want. And once you feel you've done this and checked it out, like we have, and we run it and we checked it out, saw that it's stored, didn't have a problem, then you might say use this confirm argument and set that equal to false and say, you gave me this warning and I appreciate it, but I no longer want to see the warning, and now it's just going to run it and doesn't have any output to show you because the transform variable is being saved and not output, but it is stored in there, so if we want to access it, it is available to us. Okay, so this variable that we've been transforming, the abortion rate, is an interval level variable, the number of women per 1,000 who have abortions in different states. Interval level data is all well and good, but there may be some instances where we want to change the level of measurement from interval level to, say, ordinal level, to maybe identify broader patterns in data not visible at the interval level. And we have different types of a different type of transformation to accomplish this. So I could say the type of transformation I want to do is cut, and cut will separate the states by abortion rate, like into tiers, and then generate the ordered values of the abortion rate. So let me finish this code to show you what it looks like. So if you use cut, you've either got to use cut points argument or the group argument along with it. So let's try the groups. I think that's probably a little simpler. So groups is used to specify the number of groups. So let's say I want 3 groups, and I'm not going to save the result so I can see it on the screen. So we are going to cut abortion rate into 3 groups. and we can see the results here. So it's giving me an interval notation for what range these are in. The low range is 0.9 to 12, and then 12 to 18.3, and then 18.3 to 40. And these should be roughly equal size groups. It's not strictly possible with 50 states to put them into 3 equal size groups, because 50 isn't neatly divisible by 3, but it's doing as close a job as it can. Now, we set the cut writes here to make equal size groups. If we wanted to use different numbers and have unequal size groups, we could use this cut points argument. So I will say cut points, and cut points needs to be, as it says here, a vector of values to serve as lower bounds of the rank categories for a transformed X variable. So I'm reading that right. We will use the concatenate function to create a vector. And if we're doing the lower bounds, so I'm not sure if we start with 0 or not. Let's see what happens if we say cut points are 10, 20, 30. Well, let's do that. 10, 20, and 30. It should make 4 groups. Let's see what happens. Do we want to continue? Yes. Okay, nice. It did what I hoped it would do. So the first group goes from 0.9 to 10, and then this not including 10, and then the second group 10 up to not including 20. Then we got 20 to 30, and then 30 to 40, and you can see each state and which group it is assigned to here. I haven't saved the result, but as in the last video, you can save the result by assigning the output of the transformC function to a new object or to a new variable within the existing data set. But you got to be careful not to overwrite your existing data when you do that. Now I want to talk about this dummy type of transformation. This is to use to transform a variable and to create dummy variables from a variable. And we don't do that with interval level variables. We do that with categorical variables, so nominal or ordinal level variables. Example I might use is the voter ID law variable in the states data set. Before I transform it, let's take a look at the original coding of the variable. It classifies states by the strictness of their voter ID requirements, going from the first state with photo ID requested, and then I believe there are 5 levels. We can see them listed here. So what the dummy variable would do would be to take this categorical variable information about the voting ID requirements in different states and assign the value of 1 to a certain category or categories, and then 0 to other categories. I'm just going to run this and see what it says by default. So it tells us that we need to please complete the function's response argument. So what the response argument is doing is saying, of the 5 levels, which is the 1 category, or which is the category we would include. So we got to tell it what is the response to be coded 1. And it's kind of helpful. It says the options are photo ID requested, non-photo ID requested, strict non-photo ID. So which one do we want to use? Let's say, for example, let's use no document required. And I'm copying and pasting this because it is going to try to exact match the value to code it 1. So to avoid typos or some issue with capitalization, I'm going to look at the levels and then copy the value and then paste it. So let's run this and see what happens. So now I have an output, 50, a vector of 50 values, 0s and 1s, and then the 1s are the states where no document is required. So in the 5th state, there's no document required. And just to confirm, so in our 5th state, there it is, no document required. And so that would be useful. This kind of dummy variable would be useful if I wanted to compare states where no document is required to vote to all other states. Okay, so now I want to get even more crazy with my use of the transformC function. Let's say I wanted to create a dummy variable and I want to identify the states that identifies the states with the strictest 2 categories of voter ID requirements. So they are states where I want to identify states where strict photo ID is required, or they have a strict non-photo ID requirement. So these are 2 levels that I want to make the response. And as I mentioned before, I like to copy these into the argument so I avoid typos and type less. So but this isn't going to work as is. It needs to be a vector. The response can be one thing, and the one thing it is in this case will be a vector. So I'm going to use that concatenate function, separate these 2 values by commas. One is strict photo ID, the other is non-strict photo ID. And then the last thing I need to get these in quotation marks. They're not named objects, they're variable values. So I'm going to make a dummy variable out of the voter ID law where the response category to be coded 1 is either a strict photo ID or a strict non-photo ID. Let's run that and see how it looks. We want to confirm it. Sure, let's go. Okay, now I've got 0s and 1s where some states are coded 1 and some states are coded 0. To get a real good look at this, I'm going to save the output of this transformC function to a new variable in the data set. I'll call it voter ID strict. So some states have a strict requirement for photo ID or non-photo ID, and I'm creating a dummy variable to identify those states. And then to really see what's happening here, I want to make a quick little data frame to put the state name and the original variable voter ID law and my new variable voter ID strict. I'm just doing this so we can view these side by side and see what we're looking at. So here's kind of an image of some of our data. We've got the states named, and they are in alphabetical order in the data set, Alabama through Wyoming, and it lists our the categorical version of the variable of the ID requirements, and then how that comes out in our transform version. So you can see states where there is a strict non-photo ID are identified with 1s, as well as states where there is a strict photo ID requirement 1. And then all other levels of the variable that don't, all the states without a strict non-photo or photo ID requirement are coded 0s. So we've kind of divided the states by voter ID into 2 groups, those with strict identification requirements and those without strict identification requirements. And depending on the application, that dummy variable could be a very useful way to do analysis of voter ID laws. And that's the main optional arguments that you can use with the transformC function. It is a workhorse function that can do a lot of useful things with your data analysis. Just be careful when you're using it, especially not to overwrite data by mistake.